Hi, welcome to this section. In this section, we're going to talk about inheritance in Python. So, what is inheritance? Inheritance allows a class to inherit attributes and functions from another class. It is a fundamental concept in object-oriented programming that allows a class, let's say a child class, to inherit attributes and functions from another class that could be a parent class. Okay, this is very useful method because this promotes code reusability and helps in building hierarchical relationship between classes. So you don't have to write down one function many times in different classes. You can have a parent class where you define your function, and you can have a child class that are inheriting from the main or base class, let's say, and they can access the attributes of the base class, they can access the functions of the base class. So we don't have to redefine these functions and attributes in the child class. Okay, so instead of writing the same code multiple times, we define common properties and behaviors in a parent class and let child classes inherit them. So in this section, we're going to dive deep into the inheritance concept in Python. Stay tuned. Hi, welcome back. So there are different types of inheritance. We're going to start by single inheritance in this video. We are having a class called animal, and this animal class has one function only. And the function name is sound1. Whenever this sound1 function is called, it is going to print this message. Animal makes a sound. Okay? Then we are having a dog class that inherits from the animal class. In order to show that a class inherits from another class, we write down the keyword of class, then we type down the name of our current class, let's say the child. Then we are in parentheses mentioning for example, the parent class. Okay, so here the dog class inherits from the animal class. This is how we can show it in Python. So in this dog class, we are having a function called sound2, and whenever this sound2 function is called, this message is shown in the output. Dog barks. Okay? Now, I would like to create an object from the dog class. So we write down the object name. I call it d equals dog, an empty parenthesis, because we have no arguments to pass because we have no constructor here. Then using that object, I call the sound2 function. When I call the sound2 function, it is going to show this message to me in the output. Dog barks. Okay, this is printed in the output. However, because the dog class inherits from the animal class, using an object of the dog class, I can have access to the sound1 function as well. So I write down the name of my object, which is d.sound1. And when I run the code, I see that this animal makes a sound message is shown in the output. So one thing that we learned in this video, if a class inherits from another class, okay, let's say the child class inherits from the parent class, I can create an object from the child class and use that object, to call the functions of the parent class. This is what we learned so far. But what if the name of these two functions are the same? So we are having a parent class that has a function called sound, and we are having a child class that has a function called sound again. So in this case, when I have two functions in two classes that are having the same name and one function inherits from another function, when I create an object of the child class and I try to call the sound function, it will indeed call this sound function and not this one. Okay, so when I run this code, we see that dog barks is shown in the output. So this is the second point that we need to learn about single inheritance. If the parent class and the child class both are having functions that are having the identical names, we are creating an object of the child class. Through that object, we can only access the function that is inside the child class if both names of the functions are the same in the child and parent class. Okay. However, if the functions are not the same and there are different names here, for example, using the object of the child class, we can have access to both of the functions thanks to inheritance. So this was a very good example to understand the basic concepts of single inheritance in Python. In the following videos, we are going to talk about different types of inheritance in Python. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about multiple inheritance in Python. We would like to write a program that defines two parent classes called father and mother and a child class called child that inherits from both of the parent classes. Here is my first parent class called father. This class has one function called showFather. Whenever this function is called, we are having this message being shown in the output. Father's property. Then we are having the second parent class called mother. Then this has a function that is called show underscore mother. And whenever this function is called, we're going to have this message in the output, mother's property. Finally, we are having a class called child that inherits from both of the classes. So here, first of all, we learn that the child class can inherit from first parent class, comma, second parent class. Okay, so it's possible for a child class to inherit from two classes, or let's say multiple classes. This is how we can declare them. Then we are having a function called showChild, and whenever this showChild function is called, this message is shown in the output, child's property. So here we are creating an object from the child class. By using that object, we can access the showFather function, then showMother function, and also the showChild function. So let me run the code. When we run the code, we see these messages are printed in the output. We see that father's property, this print is shown. Then mother's property, this print is shown. Sorry, father's property, this print is shown. Then mother's property, this print is shown. Then child's property, which is this print for us. So in this video, we learned how a child class can inherit from multiple classes and how an object of the child class can access the functions of both parent classes in Python. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about multi-level inheritance. We're going to write a program that demonstrates multi-level inheritance, where animal is the base class, mammal is a derived class, and dog is a further derived class. Let me illustrate it with an example. Here is the base class, or let's say the parent class called animal. It has one function called speak, and whenever the speak function is called, we're going to have this message in the output being printed: animals make sounds. Then we are having the child class, or let's say the derived class called mammal, inheriting from the animal class. And it has one function. And whenever this function called has fur is called, this message is going to be shown in the output. Mammals usually have fur. Then we are having another class called dog that inherits from mammal. So we are having one animal class, we are having a mammal class inheriting from animal class, and we're having a dog class inheriting from mammal class. This is what we call multi-level inheritance. The dog class has a function called sound, and whenever the sound function is called, we are going to have this message shown in the output: dog barks. Now we would like to create an object from the dog class, okay, called D. Then using that object, we would like to access the speak function in the base class, then the has fur function in the base class for the dog class, then the sound function in the dog class, because dog inherits from mammal and mammal inherit from animal. So indirectly, dog inherits from animal as well. Therefore, using an object of the dog class make it possible for us to access the speak function and also the has fur function, and of course the sound function. So when I run this code, we see these outputs. We see that when the speak function is called, animals make sounds message is printed in the output. Then we are calling the has fur function, and we see that mammals usually have fur message is shown. And finally, when the sound function is called, this message dog barks is shown in the output. This is how we can manage to have multi-level inheritance in Python. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about hierarchical inheritance. So multiple child classes inherit from a single parent class. We're going to write a program where multiple classes, we call them dog and cat in this example, inherit from a common parent class called animal. So here is the parent class. It has a function called sound, and animals make sounds. Message is going to be shown in the output whenever this function is called. The dog class is inheriting from the animal class. It has the same name function called sound, and this message is shown whenever the sound function is called dog barks. And also we are having the second child class inheriting from the animal parent class, and again the same name for the function sound, and this message is shown cat mews. Okay, so now we are creating objects, one from the dog class and one from the cat class. When we call the sound functions using the dog object and the cat object, we are going to call the sound in the dog class and also the sound in the cat class. Let me say it one more time. So I create an object called D from the dog class, and I use that object to call the sound function. When I use the D object to call the sound function, this sound function is going to be called. Why? Because the D is created from the dog class. So this sound function is called. And also, I then create an object called C from the cat class, and using that object, when I call the sound function, this sound function is going to be called because it is from the cat class and I'm using an object of the cat class. So when I run the code, we see that this message is shown first. Dog barks because we call the sound function in the dog class. Then cat mews is this sound function because we use the cat object to call the sound function. So this is how we can have hierarchical inheritance in Python, where multiple child classes inherit from a single parent class. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about hybrid inheritance. Hybrid inheritance is a combination of different types of inheritance. Here we would like to write a program that demonstrates hybrid inheritance using a person, employee, manager, and engineer class structure. Here is my base class called person. It has one function that is called show. Whenever this show function is called, we are going to have this message: I am a person. Then we are having another class called employee that is going to inherit from the person class. And this has one function as well, show employee. Whenever this function is called, I am an employee message is shown in the output. Then we are having another class called manager, and this manager class inherits from the employee class and not from the person class. Okay. So whenever it has one function called show manager, whenever this show manager function is called, I am a manager is printed in the output. Finally, we are having another class called engineer that also inherits from the employee class. So we are having four classes. The first one is the base class, then employee inherits from the person, manager inherits from employee, and engineer inherits from employee as well. In the engineer class, we are having a function called show engineer, and I'm an engineer message is shown whenever it is called. Then we would like to start creating our objects. I am creating an object from the manager class, from this class, and then an object from the engineer class. Okay, so one object from the manager class and one object from the engineer class. Then I use this manager object M to access show employee, and show managers function. So the manager object is trying to access the show function, show employee, and show manager functions. How? Because we are creating an object of the manager class. So the object of this class, of course, has access to this function because this function is defined inside the manager class. Then because manager class inherits from employee and employee inherits from person, the object of the manager can have access to show employee and also the show functions. So we are going to have I am a person, I am an employee, and I'm a manager messages shown in the output using the object of the manager class. Then using the object of the engineer class, we are going to access the show engineer function, show employee function, and show. Why? Because we are creating an object from the engineer class. So of course we can have access to the show engineer function because it's a function defined inside this class. Then it can access the show employee because engineer inherits from employee, so it can have access to show employee function. And also it can have access to show function because employee also inherits from person class. Therefore, the object of the engineer class can access to this function, and this function. So whenever these three functions are called, we are having these messages: I'm a person, I'm an employee, and I'm an engineer in the output. When we run the code, exactly we see what we expected. I'm a person, I'm an employee, I'm a manager, using the manager object, manager class object. Then using the engineer object, we are having these three messages: I'm a person, I'm an employee, and I'm an engineer. So we see that we could have a hybrid inheritance, and using the objects, we could have access to different functions. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about a keyword called super in calling parent class method. So the super function allows access to the parent class function inside the child class. Let me illustrate it with an example. Write a program that demonstrates how to use super function or super method to call a parent class method or function inside a child class. Here is my parent class called animal. We are having a function called sound. And whenever the sound function is called, this message is printed in the output. Animal makes a sound. And we are having a child class called dog that inherits from the animal class. We are having a function called sound, and whenever this sound is called, this message is shown in the output. Dog barks. Afterwards, we are creating an object from the dog class. Then we use that object to call the sound function. So when I run this code, we see that dog barks is shown in the output. But what if I would like to also call this sound function from the parent class, that they are having the same name? When they are having the same name, when I use the object of the child class, this sound function is called. There is a solution for that. In order to call this sound function inside the parent class, we can use the super function. So we type down simply the super keyword with empty parentheses, then dot, then the name of the function in the parent class. So whenever this function is called, we are going to first call the sound function in the parent class and print the animal makes a sound message in the output. When the call of this sound function is finished and everything in that function is executed, the compiler finishes this line and goes to this line, and it is going to print dog barks. Let me run the code. Now, when I run the code, here we see exactly the same thing. So I created an object from the dog class. I use that object to call the sound function. Still, this sound function is being called. Whenever this sound function is called, the first thing that is going to be implemented in this function is the super function that is calling the sound function from the animal class. Okay, now we are here. The compiler goes here, call this function, and print this message. Animal makes a sound. This is why we are having it in the output. Then when the execution of this function is finished, it comes back here, it goes to next line and prints dog barks. So in this video, we learned how we can use the super method, or let's say the super function, in the child class in order to call the function in the parent class that has the same name as the function that we have in the child class. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about method resolution order in multiple inheritance. We would like to write a program that demonstrates method resolution order using multiple inheritance. Imagine that we are having class A, one function is called show, and whenever this function is called, the class A message is shown in the output. Then we are having a class B inheriting from A, and it shows, it has a show function again, sorry, and it prints class B whenever this show function is called. Then we are having a class C, again inheriting from A, and it has the same name function again, and it prints class C in the output whenever it is called. Finally, we are having a class called D that inherits from both B and C. So it's a multiple inheritance for this one. Then we are having a keyword pass. So we don't want to do anything in the class. In order to say that to Python, we write down the pass keyword. Just do nothing inside D. Then we are creating an object from the class D here. Okay, here is my object called D from the D class. Then I call the function show. And we see that we have no function called show in the D class. Now, you think that which one of these show functions are printed in the output? So when I run this code, we see that class B is printed in the output. So this function show is called. When I call the show function using the object of the class D, because D has no function called show, this function is called class B. And why not class C? And why not class A? So here is the logic. The class D inherits from B and C, and Python follows method resolution order using the linearization, okay? So we are going to go from left to right rule. Therefore, D inherits from B and C. And Python looks for the function show in D, and D doesn't define it, so D doesn't have it, and we wrote that pass, just do nothing in D. Therefore, it follows the method resolution order, which is this one. So this is D. It checks for the function show. It does not find it. So it goes for B. It goes for class B. Then it goes for class C. Then it goes for class A. Okay, so, and because the function follows the method resolution order, from left to right, a rule is defined in Python. So left to right priority, let's say. Here, because first it inherits from B and then C, so class D has the show function? No, it does not have it. So it follows this left to right priority. It checks the class B. Class B, does it have the show function? Yes, it has. So it is the first time that it finds the show function, and it is inside the class B. So it executes this show function that is going to help us to print class B message. Let me illustrate it one more time. So Python follows the method resolution order. It means that from depth to first or from left to right rule. So from left to right has priority. First, we are creating an object of the class D, and we call the show function. So the Python starts searching in class D to see if it finds a function called show in class D. And we have no function called show. Therefore, it is going to go for class B because it's on the left side. It is more on the left compared to C. So it is going to go to class B. And then C, and then A. Okay? B, then C, and then A. Okay? So it checks to see if it finds anything in class B that has a function called show. So it checks class B, it sees that, okay, there is a function called show, and it prints the class B because it calls this function. And then the program is terminated. So I type down the method resolution order steps here using this line so you can see it in the output. So when I run the code, we see the class B message in the output. Then we see this is how Python goes. So it starts from class D, then goes to class B, then goes to class C, and finally goes to class A, exactly as we explained here. So from left to right. One more time. We start from class D, we find the show function. No, we don't find it. So we go for the next class, then next class, and then next class. So after D, we go for B, C, and A. But when checking the class B, we see that there is a function called show. Therefore, we are going to call that function, and when that function is called, the class B message is shown in the output. This is how actually this program works and this program executed. This is called method resolution order in Python. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about default arguments. We would like to write a program where a function can handle different numbers of arguments. Here we are having a class called Matplotlib. Inside this class, we are defining a function called add. And this add function has 3 arguments, as you see here, apart from self. Argument A, argument B, and argument C. So here, this function, when it is called, it is going to add A plus B plus C. So A added to B added to C. So it is going to calculate this and return the output for us. But what does it mean that we are having C equals 0 in the arguments in our add function? We never had that before. So this is the default argument. So if I call this function and use 2 arguments, which are A and B, then by default, it is going to assign number 0 to be argument C. Okay? But if I call this function with 3 arguments, the third argument is going to replace that 0. Let me illustrate it with an example. Here we are creating an object from the math operations class, and using that object, which is called math, we're calling the add function. So math.add. Then here we are having 2 arguments, 5 and 3. So 5 is for A and 3 is for B. So when I call this function with these 2 arguments, although it requires 3 arguments here, it is going to consider A equal to 5, B equals to 3, and C equals to 0 by default when we have no third argument. Therefore, it is going to calculate 5 plus 3, so the output is 8. As you see here, when we run the code, we see 8 here. However, if I call the very same function, but this time we have 3 arguments instead of 2. Here A equals 5, B equals 3, and C equals 2 this time. So when we have a third argument, this third argument is going to be assigned to a variable or argument or parameter C, let's say. Then it is going to return 5 plus 3 plus 2. So this is what's going to happen. So what we learned from the default argument is the following. If we are having, for example, a function like this add, and it has 3 arguments, A, B, and C equals 0, it means that we are having the third argument as a default argument. Therefore, it is possible for us to call the function only using the first 2 arguments, A and B. This is why when we call the function with 5 and 3, it works and it gives us the output. However, if I call the function using 3 arguments like 5, 3, and 2, that last argument is going to be replaced this 0, okay, and c will be equal to the last argument, which is 2, and then it is going to calculate a plus b plus c. This is how we can work with default arguments in Python. Thank you for watching.